Hi everyone and welcome back to Matthew Wister. Today we're going to be talking about nuclear fission and fusion and nuclear chemistry. So fission is when a neutron is bombarding an unstable nuclei, splitting it into two or more smaller and lighter atoms. And this type of fission reaction is going to release a lot of energy, especially through a chain reaction. So once the neutron hits the uranium, which is an example, it's going to keep on hitting it and hitting it and hitting it. And the energy is going to progressively start to decrease. An example here is how the neutron is being absorbed by the uranium, causing the unstable uranium to break down into smaller, lighter nuclei. Now, fusion is when a small nuclei forms a larger or heavier nucleus, and it's also going to release a lot of energy. An example here, we have the two hydrogen atoms fusing into helium and releasing neutrons and energy. But fusion is going to require high levels of temperature in order to actually occur. Now, here are some practice problems. So the first one is asking which pair of nuclei can undergo a fusion reaction. So fusion begins with smaller nuclei. So that means that they have a smaller mass and it's going to be converted into energy. So when we're looking at these, the pair of nuclei that have the smallest mass would be D, hydrogen 2 and hydrogen 3. Because again, fusion involves a combination of two lighter nuclei, and hydrogen 2 and 3 have the lightest mass. Now the second problem is asking us to determine which type of reaction is happening. So it's either fission or fusion. When we're looking at it, we can see two hydrogen atoms or two hydrogen nuclei are fusing together to produce helium and release energy. So the two smaller nuclei are forming a larger one, which is fusion. Now for the last one, it's saying that the accompanying diagram represents a nuclear reaction in which a neutron is bombarding a heavy nucleus. And we can see here that the neutron is bombarding uranium, and it's releasing a lot of energy and neutrons. And we can see in the graph that it actually has smaller fragments. And again, we see that it's bombarding it, and there's energy and there's neutrons. So we immediately know just by using the graph that this is a nuclear fission reaction, because there's a neutron that's bombarding a large and unstable nucleus, causing it to split into separate, smaller ones. Now that we know the basics, we can do some nuclear chemistry where we're going to balance a nuclear fission equation. So we know that this is a nuclear fission reaction because we have the neutron and it's bombarding the uranium, causing it to break down into these smaller nuclei and releasing a lot of energy in the process. So whenever we're balancing a nuclear fission reaction, we need the total mass of reactants to equal the total mass of the products, as well as the atomic number in the reactants and the atomic number in the products. So we're going to split this into 4. Now, we need to find what this missing element is, and its corresponding atomic number and atomic mass. But to do that, again, we need to solve for it mathematically. So on one side, we're going to have the total mass of the reactants, and the other side is going to be the total mass of the products. And here we're going to have the atomic number of the reactants and atomic number of the products. So just to refresh your memory, here we have something in AZX notation. And AZX notation basically means that A is our mass, Z is our atomic number, and X is our symbol. So now that we know that, now we can add the values on each side. So since we're looking at the mass first, we're going to have to look at the top number because that is our mass. So we have a 1 here, and we have 235 here. That's going to equal 236. Now in the product side, we have 137, we have our unknown value, and we have 2 times 1, which is going to be 2. Now the reason we're doing that is because even though the neutron has a mass of 1, since there's 2 neutrons, we're going to have to multiply that. So it's going to be 137 plus whatever the mass is plus 2, which is just 139 plus A. Now we have to set these equal to each other because again, we need to solve for them. So we're going to write 236 is equal to 139 plus a. And we're going to subtract 139 on both sides because we want to isolate the a variable. And we're going to get that a is equal to 97. So that is our missing mass. But now we need to figure out the atomic number. So now we're going to look at the bottom number. So in the bottom, we have a 0, we have a 92. So in total, we're going to do 0 plus 92, which is just 92. Now in the products, we have 52, our missing one, and 0. Because even though we have 2 neutrons, since the atomic number is 0, we can't really multiply it because we're still going to get 0. So our atomic number in the product side is going to be 52 plus z. And now we're just going to set that equal to 92. We're going to minus 52 on both sides. And we're going to get that z is equal to 40. And 40 is going to be our atomic number. So right now, what we're going to have for our missing values, so again, we have our A, Z, X notation. A is our mass, Z is our atomic number, and X is our element. So we know that the mass is 97, and the atomic number is 40. So now all we have to do is look in the periodic table of elements and look for which element has the atomic number of 40. And that's going to be Zr, or zirconium. And that's your answer.